I just wanted to introduce our guest speaker for tonight. Georg is someone I met. Ray and I both met in Argentina. We were really impressed with his presentations about photogrammetry and Stellarium software and how that's progressing. So without further ado, Georg, you're up.
Yeah, well, then, yeah, for you it's good morning. For me it's good evening. I'm Georg Zotti. I'm sitting in Vienna, Austria, and yeah, thank you, Greg, for your introduction invitation to this meeting. We met at the Oxford conference, and well, I'm one of the developers of the Stellarium desktop planetarium software, and I would like to give you some impressions of what can be done with it and how it can be used for virtual archaeoastronomy. Now I'm trying to share my screen if I can. All right, do you see that?
Yes.
Okay, perfect. So,
do you have any scrap paper?
first of all, I would like to introduce you to Stellarium if you really don't know it yet, and then talk about virtual archaeoastronomy, about landscapes, about the mixture and possibilities, how to visualize architecture and skyscape, yeah, actually, I had to leave away the game engine stuff, but I can still, if there's time, I can then also talk about outreach initiatives and Stellarium use in a museum. Now, is there anybody who does not know Stellarium in your society? Just to say some words, it's a multi-platform program that works on all the major desktop platforms and provides a pretty good sky simulation. You can have lots of projections, exchangeable constellations patterns, which makes it very nice also for ethnoastronomy. And you can add your own photographic horizons, which is very useful if you have particular sites that you want to, where you want to visualize the sky for. And the program is plugin extendable. That means you can add more features as you need them. So we are cultural astronomers. There are astrophysicists, there are observers, there are, I added the plugin for calendars. So there's lots of stuff that you can do with Stellarium because it's an open source project. So the source code actually is free to look into. We are hosted on GitHub, and you can add your own fixes. This is how I started in 2009 when I first saw Stellarium. It was not really accurate. But well, I worked hard to make it to improve upon that. So just a bit of history, because in last autumn we just had our version 1.0 finally. So it was started in the year 2000 by Fabien Chéreau, a French student at that time, and he collected a couple of programmers who I call them the first team. They were active until about 2012. We can say Stellarium has about 10 really major contributors at the moment. So for the last 10 years, we were two people. That was Alexander Wolf and myself working on the program, maintaining it, adding it, improving it. And finally, last year, we gathered two more developers. Now we are a team of four. Of this team, I would say three are very active at the moment. The project founder and his brother founded the next project, that is Stellarium Web. So if you're using Stellarium in a web browser, this is the next project that is not the project that I'm talking about. Stellarium Web has its own pluses and minuses. I don't know the source code. I cannot really comment on that one. There is a website for this and a forum for this one. I'm talking about the Stellarium desktop version only. So some statistics, we have about 160 contributors in all, with 22,000 commits. That means 22,000 steps in development. Some large number of lines of code. It depends on how you count that. I've seen also larger numbers in the statistic. Stellarium is translated to 80 languages, and we have also financial support site. So if you like Stellarium, of course we are happy if you can also support the development. We have 4 regular releases per year, and these show about 270 to 700,000 downloads per release. So that's really quite something. Of course, most of those are amateur astronomers. There was the huge surge. The American eclipse in 2017 was the one where we had these 700,000 downloads. Now we have a stable 270,000. That's still quite a lot. As said, translation is a big topic, of course, not from English to American English, but in many other languages. If you know some particular languages, even for the Native Americans, maybe they have their own languages that they want to see in Stellarium. It's up to them to register a language and go ahead and make it available also for their people. When you hear Stellarium, I have to say Stellarium is not equal to Stellarium, so whatever this means. Somebody still run version 0.10 or other very, very old versions. That's not really good. Just a brief history. Years ago, there was a fork that made its way into small planetariums. From this, there are other forks. There is the Stellarium mobile version for your smartphone. This has more modern features. Then there was yet another planetarium out of that. There was a new planetarium that is not source code derived from Stellarium. That's the next version of this Nightshade. And then there is Stellarium Web now on that runs in your web browser. And there even was a Stellarium for Java. So this was a dead end. So this has been there's no further development on that one. Now I started about 10 years ago, now 12 years ago. I needed that for a project in archaeoastronomy, and I saw what Stellarium looks great, but it's not really accurate. So many of the improvements that you see here were also my work. And now in October, last October the 1st, finally we had our release of the version 1.0. That is based on an update on the Qt programming toolkit, and then it was finally time that we declared the accuracy problems have been solved in 2 years ago, and this was now the software modernizing update. And now we have the version 1. Now about sky simulation. When we have a regular daylight sky that doesn't look very spectacular, usually the sky is blue if there are no clouds. And we all know the real drama starts at nightfall when you see finally the Milky Way. You see thousands of stars depending on your sky quality. And if you watch for a couple of minutes, you will see, well, the night sky is not really static. It's a thing that looks almost alive. So the motions in the sky are detectable within minutes. So it's really a fantastic thing where still images don't do justice. Still, we see it should not be surprising that many cultural heritage buildings and temples and sites are in some way or another said to be related to the sky. Now we can just go there and observe the sky, or can't we? Why would we have to simulate the sky in a desktop planetarium? Well, there are several questions to that.
It's a 9-guitar view.
There are some other questions, or okay. Why do we have to simulate the sky? First of all, site accessibility. It's not possible to go onto every site all the time and go there frequently. It's possible that the site is fragile, so you just should take care of the site and not step on every stone. And the much more critical thing is the past sky. When we're talking about things that were centuries or millennia in the past, cannot be observed. The most important thing is, of course, Earth precession. That means the stars are moving parallel to the ecliptic by Earth's precessional movement of the axis. And then there's also stellar proper motion that shifts the stars within each other. And of course, there's this unhappy thing that's called light pollution that also changes the quality of the sky as we can experience it on a site. So if you're going into some area that's close to a city. It may have been 3,000 years old, but now it just looks different. The sky quality is not the same thing as would have been experienced 3,000 years ago. And simulation also, if you have the model, vastly can speed up your research. So if you want to observe the course of the sun, you have to go to a site for half a year at least to see all the possible solar illuminations. If you want to observe the moon, you have to go there for half of its 19 years period. So that's really a long thing, and you can just replay that within a couple of minutes in your desktop planetarium. Now, what do we need for such a simulation program? I would say we need accurate planet positions. Stellarium for ages has used the VSOP-87, the classical model. We have now added the possibility to also read the JPL-D 440 and 441 computations that provide planetary positions for the years minus 13,000 to plus 17,000. That means it's quite some time span. I added the precession and obliquity models from Wondrak and others from 2011. That's a long time model of the motion of Earth's axis. I added nutation, that's the small scale bubble of Earth's axis. Then there was no idea, 10 years ago, there was no idea of the delta T motion. This is the effect that's caused by the breaking of Earth's rotation. That means Earth is getting slower in its daily rotation. This delta T is very important if you are computing solar eclipses. And finally, we now have over 30 models that you can choose from. But this slide is actually pretty old. So I used to say now we still have some open problems. One was an accurate lunar physical ephemeris. Means if you were simulating the moon for the Stone Age, it showed parts of its backside, which is of course nonsense and had to be fixed. And the other big thing that was missing in the last years was the annual aberration of starlight. That is also very important if you are talking about lunar occultations or also for eclipses. And finally, if there was one positive thing to say about the pandemic, it was that I had more time in home office and was able to finally also solve these problems. Now, after that, we said we have to modernize the code to the new Qt 6 code base and say, and then we can finally say this is now our version 1.0 after more than 20 years of development. So it's based on Qt 6. And also a new thing for the users is it also provides a new and very realistic Twilight model that is far better than the old one. It also needs better hardware, so you need a more modern graphics card, but most computers nowadays should be able to run it. We also have a very nice addition from our new latest development team member. He provided Eclipse Details. So if you're an Eclipse chaser like me, you will very much like that to plan your travels. You can even export a KML file for a particular eclipse, and then you have this map that you can load in Google Earth. So that's really a fantastic new feature that I very much like. And speaking of eclipses, the new Skylight model also is capable of providing a very nice eclipse simulation, including as the shadow of the moon rushes by and makes parts of the horizon darker. That's really a fantastic view. Yeah, I think at least one of you is also very, very fond of eclipses. And well, this twilight effect, let's see the morning twilight. You see this Earth shadow effect. So I've never seen this before in the simulation. Yeah, I've seen this on this particular site that is in Namibia. We have a fantastic clear sky, and now we can also simulate this very clear twilight for that. Yeah, speaking of simulation and placing yourselves in a particular site. So the idea of loading a landscape into a planetarium is not new. It was not an invention by Stellarium. I've seen this before, but nowadays in Stellarium we have many ways to do that. So there's one website. It's called Hey What's That? That provides you with a horizon outline based on the SRTM 90 meters model. It's not very accurate if you are close, if the horizon is close, but it's nice if the horizon is very far away, 20, 40 kilometers, then you will get pretty good idea of how the skyline looks like. But it only provides a polygonal horizon. It's not realistic. It's also very blocky. So it just has the steps from the SRTM model. Then we have already heard today Andrew Smith's software, the Horizon software. I've talked to Andrew, and he made an export version to for Stellarium. I developed a workflow that concerns and that uses Google Earth for artificial photographs. Of course, take into account that this data and the photographs are copyrighted by Google Earth, so you're not allowed to publish that, I think, without asking. The best way, of course, is if you make your own photographs together with a theodolite survey of a horizon polygon. You can combine those and make the most accurate panorama software, panorama representation of your site that you can make. Again, this is a polygon line. This is a mixture of a photograph together with a measured polygon. You can really put your photograph, make your photograph as accurately matched as possible to the polygonal line, and this provides a very good, a very reliable simulation. The software Horizon by Andrew Smith is also very good to use. If you can download the SRTM 30-meter raster meanwhile, and he can use that. But of course, it's SRTM with all its errors. So if the horizon is very close, you will not be happy with the final result, of course. So for this, you would need better software or really go into the field, go onto your site. This is the way how the Google Earth panorama looks like. This was the solar eclipse from 2017, somewhere near Rexburg. And here's the way how to make photographs. You make from one point, be it tripod or not. If you use the same tripod for your theodolite, you can just swap that with the camera and make photographs with your camera. So you can assemble those in the software Huggin, for instance, and of course they may not be straight at the point, so you need to interactively or iteratively calibrate those photographs so that they match the measured polygon line, and at some point you will find a good solution that really provides you with very good photographic coverage. These photographs have to be processed then either with Photoshop or with the GIMP. It's also free software. So you have to take away the sky and fill gaps and so on in the photographs just to make the horizon a bit nicer. And if you want to have a nightscape as well, take photographs from the same spot at night so you can see street lights and other things. Yeah, we have to calibrate that and add some city glow, and then you can have an effect like this. That's a daytime scene of the Valetta Harbor in Malta in the Mediterranean, and at night it looks rather like this. So it's terribly illuminated. It has terrible light pollution, and still this is approximately the way Valetta looks like it at night with the Stellarium sky in the background. Now, such a panorama is nice if you are only on one place. If you have one observing spot, that's perfect. Basically, such a horizon is projected onto a sphere, and the sphere surrounds you. Now, what happens if you have another viewpoint? Of course, you have to make another panorama. And if you need to cover the area in between, this gets a bit cumbersome. If you have to make 20 panoramas, it's becoming a bit yeah, nasty. So it should be easier to make that. Why can't we just walk through? And now, meanwhile, we can walk through the landscape in Stellarium in a 3D model. And the 3D model can be made with many ways. You can start with your ArcGIS project or maybe QGIS. You can start with a SketchUp model. You can build models with many other modelers. Blender is now a very good 3D modeling program. It's also free. You can use a laser scanner if you have one, and of course these are terribly expensive and heavy machines. Or you can use image-based modeling, so stereo photogrammetry, and maybe other ways as well. And in the end, what you need is what I call a georeferenced OBJ file. So OBJ is the file format, and georeferenced, I think you already know what that means. The model knows itself where on Earth it is. And just to give you an example, I made one structure, one model of a structure that my Astronomical Society of Austria has created in the outskirts of Vienna. That's a public observing site, the Sterngarten or Star Garden. There's a pyramid platform where the observer stands in the center, and the center makes all the poles and so on accurate for this observer. There's a polar disk that covers the northern celestial pole, and there are these outlying pillars that mark the position where the sun is rising at the summer and winter solstice and the equinoxes. This is all to get to know, to understand the processes in the sky. And as you can see here in the 3D model in Stellarium, that's of course, the structures are bent in the fisheye view. You see these altitude marks that are really perfectly in line with the altitude lines that are depicted in Stellarium. Or here's the polar disk that covers the northern celestial pole. And we also have the largest sundial of Austria in this Sterngarten. And depending on the season, of course, the polar disk, the shadow of the polar disk will cast around midnight, around noon. It will move over the meridian line, depending on the season. This is the equinox scene. You see here the meridian line and the sun that shines its light through this polar disk, and you see the shadow on the foot of the pillar. This is on the left, that's photographic capture. On the right, there is the simulation. It has become a bit better even, but you see the geometrical accuracy really here. It's a very nice thing how to deal with light and shadow. And with this, you can play with these well-known things like this strange snake thing at the pyramid in Chichen Itza. We don't know whether this was whether this is a historical observation or not. It's definitely not something that only is visible at the equinoxes, but it goes over a couple of weeks. Now, how can we model that? And I just added some slides while your previous talk was going on about LiDAR things. How to make a digital terrain model. Until a couple of years ago, you only got from the national authorities digital terrain models that were not very accurate. Maybe they had 50 or 25 meters raster length. That was not really accurate. And there was the SRTM mission with its 90-meter raster, which was free to use. So it's easier to get to this data. Now there's the 30-meter raster is SRTM with the Astra GDEM mission. It's also 25 meters with some spikes. There's a European raster and so on. But the real game changer came with LiDAR. Certainly, this is really a fantastic thing. Here's an example landscape. This is what you may have gotten previously with a 10-meter raster. You can start to see maybe there's a road that is cut through the landscape, but it's not too clear. But with LiDAR, you really see what's happening here. So you see everything, maybe even too much. And LiDAR can be processed. We can take away the vegetation. We can take away the houses. And then we have the digital terrain model, so the soil, so to speak. This is just essential. So how would you do that if you have a LiDAR data set in your GIS? I'm using ArcGIS. We also put in some aerial photograph onto the same landscape, and then I create a viewshed. That means I let the GIS system define for a particular observing location what can I see from here. So all the yellow things are visible from our particular location in the center, and of course these need to be included in the model. All the other things I cannot see. What behind some first mountain range, I can remove from the model because I never can see that from my side. And this makes the model more lightweight. Then we can decide whether, when the model is large, we can decide we need maybe 2 models. We need a more accurate inner area that is modeled from our LiDAR data. We may need a more surrounding model that is modeled maybe from SRTM, and we can combine all those. Then finally, we have our central site, our archaeological sites, where we may have some post holes, some pillars that we don't really know what they have been, but we have some ideas that they may be somehow aligned with whatever astronomical things on the horizon. So we can make a simple model of that and export that maybe with ArcScene or with other means. Combine all those. I use Blender to combine these sub-models. And finally, we can load all this into Stellarium and walk through the scene and check whether any posts are aligned with some directions towards summer solstice, sunrise, or other directions. So with this model, with this 3D model, you can really experience what's happening here. You can go into the scene. It's not a top-down view as you may be used in your GIS system. It's only the map view, but being in the scene, being in the 3D scene, like in a computer game, that's really also eye-opening to experience what's happening in the scene. A couple of years ago, we were able to analyze the foundations of temple remains close to Rome in the Hadrian's Villa at Tivoli. And here there was one temple that I could definitely show. The main entrance is oriented perfectly in line, the main axis perfectly in line with summer solstice sunrise behind the mountains. Of course, the mountain is very important here. And you see the orientation to this sunrise is really can hardly be made any better. There are more well-known sites like Jonquillo. I don't have to present this site to you, I think, but you can see I received some data, LiDAR data from Ivan Getzi and Clive, and I made this 3D model, and
Wow.
You see it's a large area. There are mountains dozens of kilometers away. They're also included in the scene because I can remove, of course, I can remove all the geometry that's inside the valley behind the mountains because the valleys are not visible, but the mountain ridges are important. And also in Jonquillo, well, from one particular location, there is a particular sunset just behind this fortified temple that falls in line with this formed valley in this fortified temple. Speaking of light and shadow simulation, 2014 there was a conference in Malta at the Maltese temples. We visited the autumn equinox sunrise, and I received laser scans from this temple. And as you can see, I think the simulation is pretty accurate for the same moment here when you see how the shadows are falling. Yeah, I think it's pretty convincing, and you can really do your analysis with your temple model. If the model is accurate, the simulation is also accurate. But of course, the model must be accurate. So there were some other things. This is what has been called once the Carpathian Stonehenge, similar structure in Romania, Samețegetuza Regia. Somebody said it's aligned with winter solstice sunrise. Well, maybe on paper, maybe on your map, but if you take a landscape into account, it is not. So it is pretty far off. Well, the problem is, of course, the best thing to prove that is go there and take your own measurements, take your own photographs. But I was there, and well, you see the tree line was unfortunately I was not able to do any measurements there. Also, the weather was very bad. Still, verification is always, of course, still a good topic. Now, a question about the time. Shall I have to stop within 1 minute, or is this an open-end thing?
Go ahead.
Yeah, it's open-ended. I would continue. I
Please,
think
yes.
everybody's been.
Please continue.
I hope it's interesting enough to take some more. Well, Greg also knows this one. This one was an example I gave in Argentina, the light and shadow simulation in Ollantaytambo. Just to present you this site, it was an Inca ruler, Pachacuti, created this Inca estate. Just to give you an impression, we have some terraces for agriculture. We have a sun temple, as it's called. Here's Kim Malville in front of this fantastic row of stones. This masonry is just incredible. Yeah, I hope you know this Inca masonry is simply spectacular, I would say. Here's a photo from the other side of the valley, and here are these terraces, the sun temple, and I'm concentrating on this Inca Misana, on this water shrine. And Kim told us there is this Indica Arena with what he called horizontal gnomons. Now, this water shrine is apparently it's a sanctuary for water and rocks and the sun. There is this wall that has been carved in incredible ways. There are hundreds of steps and niches and some places, walkways, and these steps lead to nowhere. There's just 4 or 6 steps that lead nowhere. It's not really a staircase that can be used in practice. But it has been said that the sun, rocks, and water play a central role in the Inca myths of origin, and of course this has to do with some mythology, with some religious practices. And apparently these staircases were some sort of communication between this world and some world beyond. I saw this the Andes are active geological regions. So I saw this folded rocks that almost look like gills for the rock. So it makes really, you can imagine that the Inca thought this rock is alive in some way. Yeah, this made this place also so special that you see these structures. Now, the thing that we were mostly interested was this Indica Arena, the place from where sees and understands the sun. It is an almost vertical wall. It's a sculpted wall with sharp-edged ledges, and there are some carved out protrusions. That means things that were left when the wall was carved. And these provide some interesting shadow effects. And this is what Kim Melville said, called the horizontal gnomons. He has written a chapter in the handbook of archaeoastronomy, where he describes it. The cliff also contains a series of horizontal gnomons, one of which, in the area known as Indica Arena, casts a shadow into a V-shaped notch in the ledge around the period of December solstice. Another notch for the second shadow may have been damaged. So that's a photograph that proves that on one particular day, this shadow works like that on that particular moment. But how long does it take? Does it work on the next day? This cannot be read in this book or in this short paper. Now, how can we make light and shadow studies in the 21st century? Of course, you can travel. Traveling has become so easy. Far too many people are traveling far too much. That's an unfortunate byproduct of this. But then you would have to stay for half a year to observe everything that the sun can provide. Or you go there every month. Of course, too much travel is bad for ecology, and you can still miss events. The weather can not play with you. You can install a webcam, but you have to convince that somebody to take care of the webcam, to not take it away and keep it running. And still, the weather can interfere with that. Or we can take a model with us and simulate light and shadow effects in astronomical software. How to model that? You can use a laser scanner if you can afford it, if you can carry it with you. So sometimes when you're traveling in a tourist group, the this travel in 2011 was the post-Oxford conference tour of 2011 in Lima. And of course, I didn't have a laser scan with me. But I knew it's possible. It was technology that was very new at that time. It's possible if you make a series of photographs of the same object, not in a way of a panorama as I used to make, but from all sides. There's software that is capable of doing autocorrelation and create a 3D model just out of photographs. So this is the image-based model way to make 3D models. So this was this tour. We had only 2 hours in Ollantaytambo. This was not a thing that that was planned to do. I said, okay, I know this technology exists, and I try to cover this this Indica Arena with as many photographs as I see useful. And in fact, it was only 15 photographs because we could not get really inside. We only had the outside view, but the photos were good enough to see all the details on the model. And I made the first model, but I wasn't happy with that, and it was lying on my desktop, and it was lying on my hard disk. And at some point, I met Kim and Stephen Galberg and talked about this model, and they said, well, yes, this should be published, and we decided we should work on that one. So I reprocessed the whole thing with Argisoft Metashape. And I've seen the title, so you know the process. So you have a couple of photographs. You make the software is able to align the camera positions that make what is first called a sparse point cloud, which you then densify. What photoscan needs, of course, is some sort of scale. So if you don't have a scale with you, some measurement unit, then the program will provide you with the model which is unscaled. And if you have no surveyed marker points, the model also doesn't know where it is in the world. So if you only have the photographs, the model is neither scaled nor oriented nor properly georeferenced, geolocated. But you can play tricks with that. So first we have this sparse point cloud. Then with some further processing, you get the step to the step of the dense point cloud, from which you can make the 3D mesh. First of all, we can thin out. We can clip away things that are not interesting to us. So to keep the model in a modest size, and then we create the textured mesh. Now, as said, we can estimate now approximately how large the model is. So I can say, well, these things are human made, so you can get some scale, which is not, the scale is not so important. Far more important is the orientation. Now, I did not have any fiducial markers. I did not survey the thing, but what I had in the scene was shadow, and shadow is crucial for that, for this trick that I'm telling you now. I keep the time in my camera always very accurate. So I try to really keep the time. So the photographs knew the time, the photographs knew the location, and the photos recorded the shadow. And with this shadow, it's possible to fix the orientation of the model. How can we do that? We need a program that has its own shadowing model and shadowing mode. And I used SketchUp for a couple of years now because it's very easy to use. Unfortunately, SketchUp is not very capable when it comes to importing highly detailed models from other sites, from other sources. So we have to clip away everything that's not necessary for this step, and reduce the model really to the most important sites here, to the most important bits of where the shadow is visible. And then we can import that. We can first of all geolocate it. Nowadays, it's only possible, the free version of SketchUp 2017. I used SketchUp 2017. That's the last version that you can download, install on your computer, and extend with plugins that you can write yourself in Ruby. Nowadays, either you have to buy SketchUp, the Pro version. It's not really very affordable for that. What we need for that for our job, and or I've never used the now they're offering a SketchUp version that runs in your web browser, and I think you cannot extend that with Ruby scripts. So if you still find it, SketchUp 2017 is good, very easy software. Or you really take the big step and learn Blender if you have the time and 3D capabilities to invest, because Blender also has a fantastic sun mode. Now, if I place this model onto the right spot, so onto the right geolocation, SketchUp knows where on Earth it is. Now we still have to rotate the model so that the illumination will fit. And if you see here, I hope you can see my mouse pointer here. You see this horizontal gnomon, and there are two shadows now visible, one dark shadow and one lighter one. And also here, this wall has two shadows. So one shadow is the one that is captured in the photograph, and the other shadow is the shadow that comes from the simulation for the same moment where the photograph was taken. Of course, that's wrong. So the orientation of the model is wrong. And I now have to play with orientation settings in the software, rotate that until both shadows coincide. That's the easy trick for that. And now I have shadow simulation that is accurate. Now the model is really properly oriented. Of course, still, I would recommend, if you're planning your surveys, of course, do some real place fiducial markers into the landscape, make proper coordinates for those, and then you get a better process also in Photoscan. You can add those points into Photoscan Pro, or now it's Metashape, and make properly georeferenced models. Now, what can we do now with this model? So we have this photographic proof from the paper, and now we have a model that can also show the shadows as they are moving over the surface of our model. So this is what Stellarium can provide you with. You see that this shadow finger now creeps into this V-shaped notch, just as is visible on the photograph. And the other one, this other shadow finger, goes into this side and then moves lower down, just along the line where the cavity has been carved out with some instruments. Let's have a close-up here. So we start with the Meridian Sun. We have this notch, and we have this probably broken notch, or maybe it's just what we should call a left edge that has been made on purpose. So maybe this second thing was not a second V-shaped notch, but just carved like this, also already in the original. And please observe how this shadow does not come onto the horizontal part. It stays behind on the back wall until this point. Now of course it goes further, but it always stays on the back wall. This is for December solstice, and also the other shadow nose here goes just along the line on the wall. I think it's a fantastic show here. And now the big question is, so that's the process, how it works in December. Of course, December solstice is something that you cannot really identify the very day, because the day-to-day change in declination of the sun, as you all know, is very small. But another observation has been recorded in the paper. It has been recorded by Stephen Galberg in his book on Inca. At the time of the zenith sun, the shadow of the three lower gnomons are said to touch each of the three lower steps. So we're talking about these steps here, and just observe here, there's a chiseled corner, and here is the shadow of one of those gnomons. And now just observe what happens. Where this shadow goes down, that's exactly in this chiseled corner. on the day of zenith passage. That's the exact day of zenith passage, and it goes right along this corner. And now, as you can see, the pillar is now on the back wall. We have a vertical black pillar, and we have a second vertical black pillar that is practically in line with this step. And we have the notch covered in shadow. Just covered in shadow. It's not going further. It's not going onto the part of the stone that protrudes here. It's just on the back wall. I find it pretty convincing. And now the big question is that how does that behave 1 or 2 days earlier or later? Can we really identify zenith passage with that? So 1 day earlier, this shadow drops further on the back wall. So it does not really creep in the first part of the shadow, the first bit of the shadow does not really creep in this chiseled edge. You can really observe that from day to day. That's a really fantastic thing. That's zenith day, and on the next day, there's already part of the shadow of the first bit of shadow that goes along this this protruding step on this vertical wall of the protruding step. So this is, I think, this is really amazing. This is really a fantastic thing that you can see the day-to-day motion captured in this shadow device. That's very nice. It's also here that we have on the good day, we have these effects here with a vertical pillar that goes from the chiseled edge. We have the second pillar that is practically in line with this step. The other step, I've not seen any effect with the third step, so I don't know what Stephen saw here. But these two, this step and this step, are very important apparently. And this notch here is fully in shadow. And let's say 2 days before the zenith, when we have an exact pillar that covers, that is just in line with the chiseled edge, the notch is still not in shadow. Or if we wait a couple of minutes longer, the notch may be in shadow, but then this pillar is no longer in the corner. So it's also very good to see here. And also the second pillar is has moved further on to not be aligned with the step. And 2 days after zenith, we can say when the notch is filled, the pillars don't fit perfectly, especially this one is too far on the left. Or when the pillars are right, the notch, the shadow protrudes over the notch. It's not only the back wall, but you see it's also already on the stone that protrudes. So you can really identify zenith passage with this device, and that's really fantastic. And as you know, the Inca were very fond of the course of the sun and of zenith passage. There's another observation that may or may not be useful. It's about the equinox observation, that where somebody on site has seen sort of a face of some person who is playing the flute. For me, it's not very convincing. But as you can see here, also the shadow of this gnomon creeps along this left edge here. So maybe there's something about this one. I cannot say that. So this is a far less convincing thing than the other things. Maybe in the end, we also have this finger that goes just into this corner, while this notch is again in shadow at this moment. But yeah, for equinox, for me, this is far less convincing than the other observations. Of course, archaeologists are rather skeptical about this. So the official statement of some archaeologists is this one. They're describing the back wall. And then they say, all three of our archaeologists agree that the back wall is part of a building and the gnomons were not exposed originally. Well, for me as a non-archaeologist, I say, okay, I can also see that. I can see this dark line where maybe there was some sort of roof attached. But yeah, these low walls, there may have been walls to cover the whole thing from the side of just anybody. So maybe only particular people were allowed inside, were allowed to go into the building and do some observations. And who says that this roof has been there permanently? So maybe it was a folding roof, maybe the roof was opened for particular dates just to observe during a zenith passage. So I can very, very well imagine that there was some sort of hole in the roof or some sort of arrangement that the sun could be let into this building to observe zenith passage. Well, so much for light and shadow simulation. Now, I hope if you're not in a hurry, I can continue and tell you some about some museum installation. Maybe 10 more minutes, Greg, or do you want to?
Yeah, like
Okay.
so. Yeah.
Right.
Can I ask a question real quick?
Yeah. Sure.
This is Brian Bates. I was actually at this site in 2016, and I looked at it and I said something's going on, but I didn't know what. If you go back to that site, how do you know that the dark line across there is that dark line desert varnish? It's manganese oxide from water and bacteria. Do you know
Well,
about this?
I don't know any. I don't know any particular things, but I can follow arguments that there was some roof attached at this area. It looks like it could have been, but I cannot prove anything. So this would be up to archaeologists to really define what has been there in the last couple of 100 years.
I would say it's up. I would think it's up to a microbiologist to see if that was in part created by bacteria.
Yes, sure. Yeah, but let's say if there's a some roof that is constructed from wood and leaves and some cover, of course, you will have some moisture that keeps inside this wooden grassy thing, and of course, bacteria can grow in this moist environment. But of course, yes, somebody, not me, but somebody should go there and take measurements, take samples, and analyze why this bit of the rock is dark here. For me, it's plausible that there has been some way to increase the moisture of the rock, and this is if there was some wooden plank attached or some grass or leaves, some sort of roof that has been constructed out of leaves. It is perfectly plausible. But I cannot prove anything about it. But I mean, the same thing can also be constructed in a way that it can be taken away for particular occurrences, for particular celebrations or observing events.
Thank you.
All right. Yeah. Thanks for the question. Yeah. This is well, moisture, bacteria, whatever. Now, my institute is very active in archaeological prospection, and one of our keystone projects was Stonehenge. We made archaeological prospection of magnetometry and ground penetrating radar for the UNESCO area around Stonehenge. And my director likes to make exhibitions, and one of his exhibitions was around Stonehenge. And well, Stonehenge, I don't have to explain Stonehenge to you, hopefully, is maybe the most well-known site of archaeoastronomical importance, also about the history of archaeoastronomy. And so we tried to convey something to the visitors. We had a model of parts of the stones of Stonehenge in our exhibition hall. It was a two-story hall that extended both floors. And in the upper part, we had a screen that was 4 meters high and 25 meters wide. So I had 100 square meters to fill with projection. We used 5 projectors with an overlapping installation and installed what I call the Skyscape Planetarium. We had parts of the horseshoe in replica, in this replica installation. And I created Stellarium script. So, you know, Stellarium is also scriptable with a sort of JavaScript with a narration that showed our visitors, explained the site. We made sweeps along the site as it has been built, as archaeologists nowadays think the site has been developed, and also other neighboring sites. And whenever there was the chance to show some little bits of archaeoastronomy, I tried to put that in, of course, because when we're using a program, when we're using Stellarium, we have the chance to see, to show also the difference between the course of the sun then and today. So, Earth's axis is not stable, and the equinoxes were further apart than they appear nowadays. Here just some impressions of this installation. The funny thing is, although this was only a classical horizon panorama, just by different day simulation, it appeared almost three-dimensional. Although these were static panoramas. For this, we created also a remote control application, so you can now operate Stellarium with your web browser or with the web browser on a second screen or on a tablet. And here you see the difference between a sunrise then and a sunrise today. And for me, the nicest things were nightly tours. So flashlight tours for children, for age group apparently 6 to 10. They had a tour guide, and they were walking through the museum with flashlights. And at some point, they were waking up a man from the past who was sleeping there. And of course, this man from the past could not talk German. He had some, well, we could not understand his language, and he could not understand our language. So he had to express himself in different ways. And he partially explained some exhibition bits to the children. It was, I think, a pretty nice thing. And this was also in mid-twilight. Let's not twilight, in the middle of the night, let's say. And there was the installation of Stellarium with the stones and the starry background with glimmering stars, of course, made by Stellarium. And at some point, at the end of the tour, somebody had to initiate Twilight, so that was me with my tablet in the background. And well, this man from the past then pointed to the screen and said, come on, the sun is going to rise. And they made, of course, it was the summer solstice sunrise scene. And this nightly tour ended with a sort of ceremony played by this man from the past, and children were dancing and singing, and it was, I think that was really a very nice installation that you cannot do with a static movie. So we could have produced a static movie for the 20 minutes daytime show, but in this case we wouldn't have had the chance to have these nightly tours. And having an interactive planetarium of this size, that's really almost magic. With the big stone replica in the foreground, and what was too big for the hall we had on the screen. It was really a very nice show. Other things that you can do with Stellarium is this remote sync plugin, where you can put together several computers and they would show almost the same scene. You can synchronize them completely, that they really show the same scene, or you can exclude some properties, as we call that, from synchronization. Then you can do almost the same thing, just operating one screen, and the other screens are slave screens that do almost the same, maybe with some exceptions. For instance, you can show several different sky cultures, or you can have one on one screen. You can operate a telescope and see the close up, while on the other screens you see you see wide angle views. So that can be very helpful. I added a calendar plugin in the last couple of years. Now I think I still have some more calendars to implement here, but I'm mostly done. We can simulate lunar eclipses. Nowadays they look better than this one. But of course, a lunar eclipse is always a compromise about contrast. If you've ever photographed a lunar eclipse, you know that how difficult it is to photograph the bright and the dark side. I've been fighting for this for 20 years at least. And still nature wins, so we cannot simulate everything. This lunar eclipse with a Mars in opposition together with a thunderstorm is nothing that the simulation can really do properly. We have a solar eclipse simulation. This is my corona from Mongolia. It's now built into the program. with Comet Tails, I'm still dreaming of the comets from the 1990s. So this is my photograph of Yakutake and the simulation together with that. I have not seen this one. This predates me, but still the simulation is not too bad, I think. We have Ikeya as well, just before my time. It does not look too bad in the simulation. We cannot simulate everything. So McNaught was just too spectacular. The simple model that I made just as a parabolic shape, this does not cover everything that has been observed. Stellarium has access to what is called the HIPS, the Hierarchical Progressive Surveys from the astronomical community. These are surveys in other wavelengths. So you can have the infrared sky, radio sky, X-ray sky, whatever you can get together with a 3D model of a radio telescope. You can simulate supernovae. And well, speaking of supernovae, if you have historical records, these may be from other cultures, so you can show the supernova of 1055 in the ethnological context of Chinese constellations. It's also a very nice thing. And now this opens my last topic, sky cultures. Stellarium is one of the few programs where you can exchange constellation patterns and show the sky as it appears to other peoples. So the current status, as you know, professional astronomers just said the IAU just has the outline, the region in the sky. That's the constellation for the International Astronomical Union. Most amateurs know these stick figures, or from all the atlases, we have this figure artwork. We have asterisms. These are just in-between figures that are not official. Or we can also have these very long lines in the sky that help you find your way. We call them ray helpers. And we can, as said, show also other figures. So that's basically the same Greek sky depicted by Al-Sufi. We can have Belarus sky and many more. Unfortunately, we had to take away two very nice samples because they have been used in planetaria, and this was not what Annette Lee would have expected. So she withdrew her contribution. But still, if you want to participate and contribute to Stellarium, be that in code or in idea or in sky cultures, in 3D model, we just received our first 3D model from Callanish in Scotland. Standing stones. You find that on the Stellarium website now in the section with the downloads. There's now one new section, 3D models, 3D sceneries, and you can download Callanish from there. They also have their own website, and if you have an interest in 3D model, we will be pleased to add at least a link, or we can also host the model if you want. So there are many ways how Stellarium is. I think it's an excellent outreach tool, an excellent self-teaching tool, a wonderful tool to really do the things that you need to be done. It's open source, and you can add things that you need to be added. That's a chance that was just not foreseeable, let's say 15 years ago. Well, with all that, now I've doubled my time, and you still are. Almost all are still here, so I thank you for your attention, and yeah, maybe you still have more questions.
It's very, very nice. One question I have is, you have tutorials or instructions on how to kind of like a workflow to get from, I think we're very interested in the shadow casting and getting a 3D model in the landscape, but also just setting up the landscape. So instructions would be helpful.
Stellarium has a user guide as well. It's we took over the PDF that has been created by one of the original team. It's expanded on that, and now it's more than 400 pages. So that describes everything of the program. One chapter is particularly, of course, for the scenery 3D, for the 3D plugin, how to configure that, how to exactly make that work together with Stellarium. I cannot teach you how to operate Blender or how to operate your 3D modeling program. You have to know that already yourself. Many guidelines are there. There's just yesterday I added some presentations also to the Stellarium website. So if you go to www.stellarium.org, you see on the lower left side, there are now 3 presentations where I give 2 talks similar to that what I just told you, and there's 1 talk particularly about landscape creation. That was it was the Theoretical Archaeology Group Conference 2016, where I first gave instructions on the workflow, how to create a model, how to create a landscape model. Yeah,
Okay.
well, of course it's a matter of training and a matter of just do it. Just take the weeks to learn that. It's really it's so incredibly fantastic what you can do nowadays with 3D modeling and going into the site on your desktop.
Yes.
Any other questions for Georg?
Yes. Is this something that you would allow us to put on our website, your presentation? And of course, we would give you credit. I don't know how we would protect it from other people using it.
Is this your website or YouTube, or
YouTube.
how would you publish that? YouTube.
On our YouTube channel.
All right, sure, yes. I will add a link from Stellarium website to that YouTube, just as a 4th presentation, if you allow.
Yeah, I could see you said it was Stellarium. What was the website that you had that link at?
So, I would add a YouTube. I would add a link from Stellarium website to that YouTube entry. If you put this into your YouTube channel, I would add a link that also Stellarium users will be able to find the presentation.
Okay, maybe it's a little bit of time, but yeah, we'd like to host this presentation on our YouTube channel if we.
Yeah,
Yes,
that'd be
please go ahead.
wonderful.
Yes.
I think Mark had a question, but you're muted, Mark.
No,
Can't hear you, Mark.
no, I didn't have a question. I was just waving to him.
Oh, okay.
Oh. Well, in that case, I want to personally thank Georg for coming and speaking with us today. And I know that I think we would like to continue working with you in the future, if you'd like to do that.
Yeah. We are open for collaboration, of course. It's not easy. So I've heard also from your discussions that getting more interested archaeologists is the big issue, of course. So we are in a small group talking to each other, but well, going out and getting attention from the archaeologists is a big issue. That's also my big issue.
And I
the
think
question is,
we can help with that. We've been working on that. Yes.
yeah. So the big question for me is where does this thing belong to? So it's not computer science. So for computer scientists, I'm doing applied programming. For the archaeologists, I'm astronomer, and for the astronomers, I'm an archaeologist. Nobody really wants to see the chances that this interdisciplinary thing really may give one working group.
One step at a time.
Yeah. Well, let's hope for the future.
Okay, and I think, Chris, I think that's the end of the show for today.
I think so. Yeah, we're a little over time, but it's definitely worth it. Thank you again so much for giving that talk. That was great. And